I have to flip my notes over. Okay, number 5. The type of factoring that we are doing now is called sum or difference of cubes. Kind of like difference of squares, only completely different. You know what I'm saying? Okay. Sum or difference of cubes. Okay, so we're going to write the formula, and then I'm going to show you how to use the formula. So the formula is, there's 2 of them. A cubed plus B cubed equals. So this is what you're going to see in the problem. And then when you factor it, this is what the factored form is going to look like. It's going to have 2 sets of parentheses. The first set of parentheses is going to be easy. It's just A plus B. The second set of parentheses is a little bit more complicated. It is A squared minus AB plus B squared. Okay, so that is the sum of cubes. Sorry, let me focus this a little bit. Okay. Next, we have A cubed minus B cubed. All right, this is A minus B. And then we have A squared plus AB plus B squared. So, there are 2 ways that I remember this formula without memorizing the formula itself, okay? One way that I remember the formula is I remember how the signs work. And I remember how the signs work with the acronym SOAP. SOAP. Like, scrub-a-dub-dub, so your armpits don't smell. You know what I'm talking about? Okay. So, for the first set of parentheses, you remember the S. S is for the same sign. So if it's a sum problem, it's a plus. If it's a difference problem, it's a minus. Same sign. Okay? The next sign is the opposite. Same sign, opposite sign. And then the last sign is always positive. And that, my friends, is how you get SOAP. Make sense? SOAP. SOAP. Okay. Next, we get our colors. Okay? So I'm going to go ahead. Let me draw out these parentheses real quick. So I'm going to write this out. We'll do it for the plus version. A cubed plus B cubed. So it would be plus, so same sign, opposite sign, always positive. Okay, so with the colors, I'm going to show you how this works. Okay, so I'm going to pick up one of my colors. Okay, so A is the first one. So you'll notice if you look at where you plug the numbers in, there is an A here, so that goes in the first half of the first parenthesis. And then in the second set of parentheses, it's A times A times B times B. Everyone see that? A times A times B times B. Okay? So I'm just going to write it like that with my color. A times A, and then A. Okay? Now I'm going to switch colors. Okay, so here's B. So I've got plus, and then I've got the second half of my first parenthesis. And then I've got A times B, and then I've got B times B. So do you see how each set of parentheses gets half of each color? So instead of me memorizing the formula, I memorize like the pattern. Does that make sense? That, I know it's kind of silly, it's gimmicky, it's weird, but it helped me to memorize this weird pattern for factoring so that I didn't have to memorize it. And then after I'm done writing it out this way, then I just clean it up and multiply all my things. Okay? So we're going to do an example and we're going to make sure that this makes sense. Okay? So here's our example problem. We're going to do 8x to the third minus 27. Now, just like our perfect square problems or difference of squares, it was helpful to recognize what our perfect squares were. It's helpful to recognize what our perfect cubes are, okay? So off to the side, we're going to write down our perfect cubes. So we've got 1 to the third is 1, 2 to the third is 8, so this is a 2 problem. 3 to the third is 27. Okay. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. And 7 to the third is 343. I don't see the numbers get much bigger than that. They could. They could get bigger than that, but generally speaking, they don't. Okay. So the first thing I'm going to do when I do one of these problems is I want to rewrite it as something to the third minus something to the third, because I need to know what my A is and I need to know what my B is. Okay, so I already know that I have an x to the third in this one, but 8 is not written as something to the third, it's just a number 8. So I'm going to look over here and I'm going to say, okay, 8 is 2 to the third. So this part can be rewritten as 2x to the third. And then the 27 can be rewritten as 3 to the third. With me so far? Okay. So now I have my little parenthesis and then my big parenthesis. And I'm going to use SOAP to put my signs in. Okay? So little parenthesis, big parenthesis. And I'm going to say same sign, opposite sign, always positive. Okay? And now I'm going to grab my colors. Okay? First color goes with 2x. So the first color does the first half of my factor, does the first half of each factor. So 2x, there's half. And then this one is 2x times 2x. And this one is 2x. See how I did that? Is everybody comfortable so far? We're good? Okay. Next, I'm going to grab my second color, 3. And I've got 3. And then I'm going to finish this one, so times 3. And then I'm going to do this one, 3 times 3. Okay? And so now I'm going to go ahead and clean it all up. 2x minus 3. What is 2x times 2x? 4x squared. Plus, what is 2x times 3? 6x. Plus, what is 3 times 3? And we're done. That's it. Beautiful. Okay, next example. Okay, for this one, let's do 125 plus 343m cubed. Now, I don't know about you guys, but I feel uncomfortable with the order of this. Anybody else feel uncomfortable? That variable came second. You guys notice that? They put the variable second? Okay. Some people leave it like this, so we're going to feel uncomfortable, and we're going to do the problem anyway. We're just going to leave it there, because it's okay. It's okay to sometimes do it in the wrong order, and it still works out, and that answer is still valid. Okay? So we could switch the order, and we could also leave it, and it's okay both ways. They're both okay. All right, so I'm gonna show you that's okay. All right, so let's rewrite it. Let's look at our numbers over here. How should the 125 be rewritten? 5 to the third. Okay. Plus. Okay. 343m cubed. How should that be rewritten? 7m to the third. Okay. So I've got my little parentheses, and I got my big parentheses. And I got my S-O-A-P. So what should my signs be? Plus, minus, plus. Okay, same sign, opposite sign, always positive. Okay, now I grab my colors. Can you grab purple? Okay, 5 is first. So I'm going to put a 5 here. And what am I going to put here? 5 times 5. And what am I going to put here? Just a 5. Okay. And now I'm going to switch colors because I was halfway done. My next color goes with 7M. So I'm going to put a 7M here. And I'm going to put times 7M here. And what am I going to put on the end? 7M times 7M. Okay. All right, so my first set of parentheses is 5 plus 7M. And then I have 25 minus 35M plus 49M squared. How are your brains? Do they understand this type of factoring? All right, if you are uncomfortable with the order that this is written in because it is not written in the standard form, because this is not written in standard form, if you're uncomfortable with the order and you don't like how this looks, you can switch the way that terms are written as long as you keep the sign in front of the term. So for instance, the 5 and the 7M here, both of those are positive. So if we were to rewrite the order of those, we would just have to keep them both positive. So positive 7M, positive 5. In the next parenthesis, we have a positive 49M squared, a negative 35M, and a positive 25. So we just have to keep that in mind when we write it again. So positive 49M squared, negative 35M, positive 25. And so now I've switched the order, and now it looks a little bit more correct because it's the order that we are comfortable with. The other thing you could have done is in the beginning of the problem, if you did not like this and you wanted it to be written this way at the end, is you could have switched the order in the beginning. 343m cubed plus 125. And if you had done that, then when you did the factoring, it would have looked like this when you used the formula. So both of these answers are mathematically correct. One of them looks more proper than the other, but they are mathematically equivalent. So they're both fine. Okay, let's do another example problem. So here we'll go ahead and do 2 minus 54x cubed. So what I'm going to do with this one, again, it's in the wrong order. So with this one, we're going to go ahead and fix the order before we even get started. So I'm going to go ahead and rewrite these first. So we take the sign that's with the term when we fix the order. So I'm going to write negative 54 x to the third plus 2. Now, if you look at these two numbers, 54 and 2 are not on the list. 2 is over here, but 2 is not here listed as a perfect cube. Neither is 54, which means this is a GCF problem. And anytime your leading number, your leading coefficient in front of the first term is negative, that means that your GCF is negative. You need to take a negative out. So I'm going to take a GCF of negative 2 out of the problem. So negative 2, and that leaves me with negative 54 divided by negative 2 is positive 27. And positive 2 divided by negative 2 is negative 1. So now I've got 27x to the third minus 1. And now if I compare, 27 and 1 are both on the list of perfect cubes. Okay, so now I've got negative 2, and now I can write it as something cubed minus something cubed. And so 27 would be 3x cubed, 1 would just be 1 cubed. And so I can write this as my little parenthesis and my bigger parenthesis. And I'm going to make sure to keep that GCF of negative 2 in the front. And then I've got a minus in the middle, so I'm going to do the same sign, the opposite sign, and then the always positive at the end. So there's SOAP. And now I can go through and I can do the colors. So first I have 3x, and so I'm going to put 3x here. And then this will be 3x times 3x, and this will be 3x. And then I need to switch colors. And so over here, here's my 1. So this will be 1. This will be times 1. And then over here, this will be 1 times 1. So at this point, I am ready to rewrite the factors in simplified form. So I've got negative 2, 3x minus 1. 3x times 3x is 9x squared. 3x times 1 is 3x. 1 times 1 is 1. And there's my answer. All right, if you are comfortable, you can stop there. If you want to see one more example, then go ahead and keep playing the video. I'm going to do one more example. All right, so last one. For this one, we're going to do 64x cubed plus 343y cubed. Okay, so we have to think of this as something cubed plus something cubed. So if we look at our list of perfect cubes, 64 would be 4 to the third. So this is going to be 4x to the third. 343 is 7 to the third, so this would be 7y to the third. And so now we're going to set it up so we have our little set of parentheses and then our larger set of parentheses. And then we do same sign, opposite sign, and always positive. Okay, so I'm going to grab my colors. I'm going to take my first color. My first color is 4x. So I've got 4x. And then for my first spot, this is going to be 4x times 4x. And then this is going to be 4x. Now I can switch to my other color. And this one is going to be 7y. So in my second spot, I'm going to have 7y. And this is going to be 7y, 7y, and then 7y. And so now all I need to do is clean up those parentheses. So my first set of parentheses is 4x plus 7y. And then my second set of parentheses is 4x times 4x, which is 16x squared, minus 4x times 7y is 28xy, and then 7y times 7y is 49y squared. And that's it. That's all you got to do. Okay, so the assignment that you guys are going to be working on is this worksheet. It's got two sides. So you've got this side where you're creating kind of a puzzle, or it's got this other side where you're doing a punch line, and you can do one side or the other. You don't need to do both. So just pick a side, do that side, and that's all you have to do to finish your homework.